I would like you to identify as many hazards on that picture as you can in 60 seconds. Okay, so I will be measuring time here on my desk, and we'll do the countdown, and I'll show you a picture, and then try to identify as many as you can in 60 seconds. All right, are we ready to go? So 3, 2, 1, go. Please count how many hazards you identified, and please put your number in the chat. I think the smallest number I see is 3. The biggest number I see is 10. Okay, and we have probably all the numbers in that range. So excellent, well done, fantastic. But you see, every person on this call is seeing exactly the same thing. Everyone is seeing the same picture. And yet, we see a difference in how many hazards we are able to identify. If, in addition to that, if we reviewed actually what type of hazards you focused on, there would be even more variability. And even people with the highest number probably did not identify hazards identified by other people. And the simple exercise already shows an important thing. We see the sources of danger differently. And when things go wrong, it's easy to say, oh, this person failed to identify hazards. But of course, I could blame you for not identifying everything, but it would not change anything. And so the question that we can ask is why people don't see hazards. Because failure to recognize hazards is a common root cause in incident investigations. And leaders often ask, how could they have not been aware of the hazards? And therefore, let's make workers aware of the hazards so that we don't have accidents. And that hazard awareness is often the foundations of many campaigns I've seen over the years. When we think of hazards, we typically define it as something with the potential to cause harm. And to cause harm, we need a certain amount of energy or force, right? So, for example, if I then hold a pen here and when I touch it, there is nothing happening. But if I really hit it, right, there would be enough force to puncture my skin. And so that recognition led to development of this thing called hazard as energy theory, which has been fantastically popularized and further developed by Matthew Hallowell. And you probably have seen the energy sources, so gravity, motion, electrical, and so on. Those are the things that, those are the either objects, energies, or substances that have potential to cause harm if the amount of force or the amount of substance is bigger, stronger than what our body can withhold. Error traps or error-producing conditions or performance-shaping factors, there are different names around that. In my experience, the front line likes simple, and so error traps is something that we tend to use. And so those may include things like procedure that is out of date and therefore not applicable or not usable, the training that did not that we needed for the job, equipment, so for example, visual similarity of valves or buttons, not tools which are not available. So these things are not hazards in the same way as the other ones I showed you. Because when you have a procedure in front of you that is out of date, it cannot harm you in the same way as touching an exposed electric cable that would give you a shock, or touching an acid or some acid that would lead to a burn. And yet, those things do increase the risk because they may either lead to mistakes or adaptations or workarounds or deviations that may then contribute to failure. Adaptations. So, for example, if the procedure is not suitable or not adaptable or is wrong, then people may create their own procedure. Or if the tool that I have, let's say my job is to unscrew some bolts, and I've got a wrench, and I try to use the wrench with all my force, and it's not moving, then what I can do, I can deal with that. I can adapt to that, work around that problem, and for example, put a long pipe on the wrench, which extends my arm or extends the wrench arm, creating a lever, allowing to get more force um, on the nut there. And so those are examples of adaptations which are dependent or driven by the error traps in place. We've got two spray cans. One is the cooking spray and another is lubricant. So if we think of a hazard, type in the chat, what would you say is a hazard? Okay, excellent. So I see that many people are drawn to the color. But what is a hazard? Hazard is something with the potential to cause harm. Does color have that potential? Well, not directly. So what has that potential directly? So it is the chemical. If ingested, that's the easiest use, most likely. But also I see that people highlighting pressure and flammability, which is, yeah, absolutely, which may be the case as well. But in terms of if in the context of cooking, so imagine you are doing a steak for your family and you are focused on your steak. Here, of course, the danger comes from either ingesting the wrong chemical or somehow this being ignited. So then what is the potential error here? So error is a form of behavior. Behavior is something that you can see, that you can observe. So if you were standing there, observing somebody cooking it with those two cans next to them, what could you see? What's the actual error?
Error would be selection of the wrong can for the purpose being used.
Excellent. Thanks so much, Heidi. Wonderful. Yes, and so that's absolutely right. So it would be a selecting, in this case, a lubricant and spraying your food with it. And now we can ask, okay, so this is error. Error is, oops, I didn't mean that, right? So I didn't want to take lubricant. I wanted to take cooking spray. And that takes us to the concept of error traps. So what are the conditions that increase the likelihood of somebody making that error and taking a wrong can? And I think this you've already highlighted that. It's the lookalike, it's the visual similarities, the color, shape, the position of different graphical components, logo, the font size, the black line, etc. And we could also say that error is, for example, not reading a label, but also please take that in the context of the task. The task is, I'm sizzling my steak. My cone of attention is on my steak. Now, steak is being prepared for a couple minutes. It's not a long cooking process, but it also requires a lot of attention and flipping it and so on. And so when those cans stand next to you and perhaps they are turned to the side, it's very easy, therefore, to grab and use the wrong one. And so here we would say that visual similarity is an example of error trap as a condition that increases the likelihood of an error. The research by Matthew Hallowell showed that using the list of the energy sources, whether a wheel or a list, it can increase the number of identified hazards by 30%. In our internal research, we've even seen an increase by 50%. And so I think this is extremely helpful tool. But then we also designed an extended tool that looks not only at the energy sources, but also at the different categories of error traps. And this wheel is available in the guidance, because like with the energy sources, having a list of different error traps in front of you significantly increases the number and the quality of those identified. People have tendency to oversimplify the sources of danger. So when we use, for example, the list of the wheel or the list of the energy sources, we have the tendency, or people have tendency to just use that word. So let's say hazard is gravity or hazard is motion. And here I'll show you 3 levels of quality. But saying that hazard is gravity is not that helpful, right? It's not specific enough. The second level is pointing to a generic risk, like a dropped object or moving vehicle. That's a bit better, but still it's very generic. And for us, in order to help with the dynamic risk assessment and develop that skill, we need to help people to develop skill of being very practical and very specific. So here, for example, when we put the pallet on the top shelf, the lighting is poor and the driver can push the pallet too far and it could fail. And so this type of articulating is effortful. It's really, it's at the beginning, it's tiring, but also then what it does once people learn to how to do it that way, it skyrockets their ability to see danger because they can contextualize and connect the different influences that affect the danger, meaning risk of failure. And we know that giving people the list of energies can increase the number of hazards identified, but does not automatically improve the quality, would not automatically lead to level 3.